example 2 says use the function f of x to answer the following. So it says find the inverse of f of x. So now we're going to look at how to do this algebraically. So the first thing that I want to do is write my equation as y equals x minus 2, right? So x's go in, y's come out. Then I want to now trade the domain and range. So now I'm going to rewrite the expression with x equals 4 over y minus 2. And now I want to use algebra to solve this new expression for y. So the first thing I'm going to do is multiply both sides by y minus 2. And then I need to distribute this x across so I can isolate the y, because right now it's trapped inside these parentheses. So xy minus 2x is 4. And in solving for y, I want to leave everything with a y on the left side of the equation, and I'm going to move everything with an x over to the right side. And then I'm going to divide everything by x. So this is one possible path to the answer. This equals f inverse. And I want to show you an alternative form of this answer. So if I complete all of these algebra steps to here, an alternative path that I could take to the answer would be, instead of distributing the x, I could just divide by the x. So I could say y minus 2 is 4 over x, and then if I add 2, oops, that should be an x. If I add 2, let's put the x there so we can see it, right, to both sides, now I have an alternative form of the inverse. So if you graphed these two equations on the same graph, you would actually get the same picture. But you can see that by just taking a different choice, we had an option here. We could distribute or divide. The answers look different, but they actually are equivalent. So determine the domain and range of f of x. So the domain and range should swap in this case, and we didn't have to do any domain restrictions. We were able to algebraically get to the inverse with no issues. So we're asked for the domain and range of f of x. Be careful on the test, because they could ask for the domain and range of the inverse. So you want to make sure you're getting these in the correct place. So for the original function, if we look back here, well, the only domain restriction I see that might be a problem for us is you can't have 0 in the denominator. So that means x cannot equal 2. So for the domain, x cannot equal 2. So when we write the domain, we want to write it in interval notation, so it's all real numbers except for 2. So everything from negative infinity to 2, everything from 2 to positive infinity. To find the range of this function, well, we can do that by finding the domain of the inverse function, because we know they switch. So if we look at this guy, well, x cannot be 0. All right, and even up here in alternative form, x cannot be 0. So I'm doing this by checking the domain of f inverse. So x is not allowed to be 0. So that means the y values that come out of the original function should be only the x values that we're able to plug into the inverse function. So this is going to be all reals except 0. Now, one thing I want to make a note of here. Notice I wrote that x cannot be 0 underneath the domain of f of x. The range are actually returning the y values of the original function. So be real careful when you're using this method to find the range. You want to make sure that you kind of make it understood that you're only using x as a reference to the inverse function, because you don't want to confuse anyone and make them think that you think these are also x values, right? We just said, well, these are the x's of the inverse. So C asks, is f of x a one-to-one function, and why do you think so? So the answer is yes. F inverse exists, and is also a function. So I was able to conclude that confidently because algebraically I was able to solve the inverse with no issues or problems. And you don't have to necessarily graph this function, but I'm going to show you a graph of it just so you can visually see that it does pass our two tests. So if you know what the graph of f of 1 over x looks like, our function f of x is just shifting the graph of 1 over x to the right two places and then multiplying it by 4. So the graph of 1 over x has a vertical asymptote at 0, but remember our function wasn't allowed to exist at 2. So we actually have a vertical asymptote there. We then multiplied the graph by 4, so all that did was make the y values bigger. So the graph of 1 over x, right, does this around 0, so when we shift it over, and it's going to do this. So you can see that this graph passes both the vertical and horizontal line test. So this is our function f of x, and that's what we were asked for.